Hey guys, I'm welcome to my channel. In this video, I'm going to show you how you can perform image augmentation using PyTorch. So let's begin. So for our example, we'll be using this image and we'll be performing some augmentation on it. First, we'll be importing a few libraries. So the other library that we'll be using, random, will be used for performing some operations randomly with a probability. I'll be explaining it to you in a bit. And then glob is used for creating a list from a folder so that we can iterate on it. PL is below. It is an imaging library. TQDM is used for showing a progress bar. It's not necessary, but we can use it. But we'll be using it over here. And this transform class from ComputerVision will be used for performing transformation on the image or augmentation, can say. So let's execute it. Next, we'll define two variables, source and target. Source is in our input folder and target is in our output folder. Target, which will be the folder in which our output will be generated. And here we'll be using glob and getting a list of all the images in the input folder. So for now we have only one image, which is the image of a car. And here source path will create a list of all the images or all the files in a folder. So here in this case, the source is our input. Yeah, so let's execute it. So we can see our source path has this list containing only one image. Next, we'll apply some transformation. So here we'll be applying 3 transformation, but there are other transformations as well. So for example, if you want to just tilt the image a bit, so you can use this random affine. And if you have a custom function that you want to apply on the image, for example, here I have created a function called rotate, where we will be rotating the image at 90 degrees and 270 degrees, which is rotating once towards the right and towards the left. So we can write lambda and then create a custom function. I'll be showing you how we'll make this function. And then if you want to make changes in the color or saturation, contrast, brightness, etc., so for that you can use color jitter. You can also use resize function and a horizontal flip. Okay, where P.5 stands for probability. So here we'll be defining that function rotate 90-70. So here in this case, it will take the image and there will be a 50% chance of rotating the image. So for example, once this function is called, it will first do a random node choice. So there will be a 50% chance of choosing any one of these. And if it's true, then it will go over here. And then again, there will be a 50% probability whether you want to rotate the image at 90 degree or 270 degrees. So for example, image might be rotated or might not be rotated. So here we'll be using a TQDM library on the for loop. Here the first argument will be our list, which is this one, and then second would be the color of the progress bar, and your position 0 means that we don't want multiple progress bars, right? And here leave true means this will the progress bar will remain even after the completion of our program. We'll print the name of our image, and then we'll open the image using the PI library and convert it into RGB. Here we'll get the base name of the image. The base name means the actual file name from our entire folder path. Here split text means that we'll get only the name of the file without extension. Yeah, next we'll be applying transformation on our images. So here we have a transformer object. We'll be applying it on the image 4 times because we want to create 4 different variations or 4 different augmentations of one image. So here we have one for loop. So here on one image, it will apply 4 different transformations randomly. Okay. Here after applying transformation, we'll get an object affine images. Then we'll iterate over this object and save each and every object to into a new image. We'll save each and every object into a new image. So now let's run this. So this is our output folder, which is empty as of now. So here you can see we have our output generated. So you can see this image has a little different brightness. It actually has a little low brightness compared to the original image. Here it has a slightly high brightness. Here the image has been applied in a fine transform. So you can see all these transformations are just random. If I delete these images and run our program again, it will generate completely different transformations than what it had created before. So yeah, this is how you can create augmented images for training your model. So I hope you found this very helpful. Thank you very much.